And welcome to day 7 of our this year's Advent of Code and in Go. Yeah, there's not much to announce, so therefore we dive in directly into the problem. Day 7, no space left on device. You can hear birds chirping and raindrops hitting leaves as the expedition proceeds. Occasionally you can even hear much louder sounds in the distance. How big do the animals get out here anyway? The device the elves gave you has problems with more than just its communication system. You try to run a system update. System update, please, pretty please, with sugar on top. No space left on device. Okay. Perhaps you can delete some files to make space for the update. You browse around the file system to assess the situation and save the resulting terminal output. Your puzzle input. Okay, so basically our puzzle input will be just some file listings or a list of commands with some file listings in between. Okay, the file system consists of a tree of files, plain data and directories which can... Okay, plain data and directories which can contain other directories of files. So this is cd/, so this is root. Then cda, which goes into this directory, and within there we have another directory and a couple of files. Then we go one further where we have another file. Okay, understood. And you go back. Okay, the outermost directory is called root. You can navigate around the file system, moving into or out of directories and listing the contents of the directory you're currently in. Within the terminal output, lines that begin with $ are commands you executed, very much like some modern computers. Yeah, I would say so. So it's basically, if you use Linux, it's similar. Or I would say it's inspired by it. CD means change directory. This changes which directory is the current directory, but the specific result depends on the argument. CDX moves in one level. CD++, CD ... I don't know, is this ... moves out one level. It finds a directory that contains the current directory, then makes that directory the current directory. CD root switches or / switches to the outermost directory. ls means list. It prints all files and directories immediately contain. Okay. Yeah, size plus name, which is for files, and directory or dir, and some name means there's a directory. Okay, given the commands, you can determine the file system looks visually like that. So with some hierarchies here, this file tree. Okay, not too surprising here. Yeah, there are 4 directories /a, d, and E, which is in A. These directory also contains files of various sizes. Since the disk is full, your first step should probably to find directories that are good candidates for deletion. To do this, you need to determine the total size of each directory. The total size of a directory is the sum of the files, size of the files it contains, directly or indirectly. Directories themselves do not count as having any intrinsic file. Okay. The total size of the directories can be found as follows. The total size of the directory E is 584 because it contains a single file. The directory A has a total size of 94,853 because it contains files F, size G, and H list, plus file I indirectly. A contains E, which contains I. Okay. Directory D has total size of, okay, as the outermost directory root contains every file. Its total size is, okay, I don't know, 48 million? Yeah, 48 million. To begin, find all the directories with a total size of at most 100k. Then calculate the sum of their total sizes. In the example above, these directories are A and E. The sum of their total size is 95,437. Okay, find all the directories. Okay, this should be doable, I would say. So, as always, we have a nice test that we, a nice set of input data that we can use for test. So just start by copying this over. So create a new file. test.txt. Yeah, we want to edit. This is basically the command that we have. Okay, but we also need a new file for our input txt. So let's copy our input, get your puzzle input. Okay, this is a little bit larger. And copy it over. Okay. So far, so good. Now let's think about how to implement this. So we create our new Go file, day07.go. That's a simple application. We want to edit. Okay. So then let's think about what are the different things that we need to read. So first we have commands, right? We have our type that is a command. And I don't know, we will see. There are different types. The command has a command name, I would say. So things like ls or cd, I think this would be the name. And then let's look at our input, or we can look at the input directly here, test input. So basically nearly every command can have a parameter. Okay, but we will see if this is something. Okay, maybe at the moment they are changing, we don't need them. So, okay, let's move this to the side so we can easily look at it side by side. Okay, then we don't not just have commands, but we also have listings, or how do we call them? There we can separate, right? We can say we have file infos or file info. Let's make it that way. And each file can have a size and a name. So name string, and we have a size. And that is just an int. Okay, then we also have directories, so it might make sense to add our new directory, our new type directory, and directories just have a name. So something else that we are missing? Of course, right? Because each file also is assigned to a specific directory. So therefore it makes sense to add this there as well, so that we know, for example, or either we store it within the file, or what we can do, we can just store within the directory our file infos that are in there, or files. Okay, maybe this is some good introduction, or some where we can use extend types. So where we can say, for example, our directories and our files, they both have a string, right? And they are both outputs that we get from this ls command. So therefore it would make sense to group those shared things of them into into one data source, or one data object, so that this is encapsulated. So for this we can use, but now how would we know this? So what would be the common, just call it item for now. I think it's not nice. And these items have names, name string. So, and then what we do is basically we just say each directory is just an item. So that then we no longer need this name here. And the same for file info. But this allows us basically to say that our directory contains within it some items, right? Where we can say, okay, we have here our slice that contains the item items that are within a directory. So in this case, for example, in the root, we would have this directory A, would have this file B, txt, this file C, dot, and the directory D. So those would be then items that end up in this directory. And those can be either of type directory or of type file info. Okay, so from looking at this, I think it looks quite sane to have our data model ready. So now let's begin with pathing all the stuff from our file. So as always, we create our input file and our error, of course, just panic as always. So this is test.txt. If error equals nil, then just panic. And now we need to read it line-wise. So again, we use our scanner. buff.io new scanner from the input file. And as always, I forgot, close our input file when we are done. Okay, so then we loop through all the individual lines that we read. So scanner.scan, and we fetch the line, the next line always from the scanner. Scanner.text. So, and now we need to figure out if something is a command or if something is a output. So, and for this, luckily we have this symbol dollar that tells us, hey, what is coming next is a command. So therefore, an easy way to check if we should handle a command when we read through the individual lines is just by checking if the first character that we read in this line is a $. Dollar. So then again, this is not working because it's a rune. Can we just convert it to rune? Or it's this way? Or do we need to do this with... This is something that I just need to see how to define runes. I need to check, I think. Ah, no, this is an int. Okay. If it's an int, then we can also... Or we just convert the int to rune, I think. This is the correct way. So, because in the end we are about the characters, and these runes are basically what are the characters. Okay, this looks better. And this is something redundant type conversion. Okay, this is already a rune. Okay, learn something today. Nice. Okay, so if we have a rune, basically, what we then want to do is basically, we path then the command, right, with the rest from the line. So when we look at the input, we know that we can start interpreting everything that comes after the second character as a command, right? Because and for that we would need some function that we just call parse command, which takes in our command line, let's say it that way, command line as type string, and it returns a command. So, and as I said, we pass our command and we just use everything that comes after the second one, after this one, I think. So this should be the second entry, 1, and everything that comes afterwards is then basically what we want to... Oh, is this so... Oh man, this is something that we should actually just try it out. Always, if in doubt, just try it out. So it's easy to just run this command line, to just run it and see what is being printed out. So return command, and then we print out our command. Printf pass command and with a backslash with a new line. So now we have valid code. We can try to run it, and then we should see if we print out as a command basically the okay, neither. This doesn't look right. Why do we print out command line even though we are here? Okay, let's dive in and debug this. I thought that this would create a new... Ah, yeah, of course it's right. It starts with CD, so I was a little bit confused. So if we continue, we see there's no blank before, and there's also no $sign, so therefore everything works as expected. Okay, but now comes the harder part. Based on the command line, figure out what kind of command do we have. So at the moment we have 3 different commands, right? We have a command that is cd, we have we have only 2 basically. We have cd and we have ls. Okay. So I would think that what we could do is basically pass this, right? So based on what we get here. So we do the same thing. We just check if command line, and then, for example, everything until 2 is equal cd. Then we know we are in a cd command. Else if command line equal to is ls, then we know we are in ls case, and we should do different things afterwards. So now the question is, what do we do with that? What should we return? So we can just return command, so we create multiple commands. So we could create a command for ls, we could create a command and map them via the name. But now this is hard-coded. Maybe hard-coded is okay for now. And we don't need this command at all. So because in the end, what we want to do is basically that yeah, I'm not sure that ls is even something that we need to consider. So I think it might be more useful if we just return our directory. Right? If we say we pass our directory, we pass our command, and then based on what we have within this command, we return different directories. Maybe we should also make sure we are not copying them always, because we are probably going to modify them at some point. So, for example, if we go to, if we have cd, then the question is, what is the coming after the command? So for this, we need to pass what is here. So basically we need to ignore this blank and then check, okay, this is an A, this is an slash, this is an E. So we need to check what comes afterwards. So therefore we say the directory, directory name is equal, and then command line, And from here, we take basically everything that comes after the third. Because we can ignore the first two characters for the command, and then we can also ignore the third one, because the third one is just this blank. So we just assign this to our directory. But this doesn't work because, no, it's unused. Okay. So, and then what we can do, we know if we have a directory name, we want to go switch into this directory. So this means that this directory has to be within the current directory. Okay, so what we are missing is currently the current directory. We need this as well. Current directory gets longer and longer, which is a pointer to a directory. Maybe make this a little bit smaller. And this too. So this means we can just edit as a... no, there's one thing. Everything that we can go into is probably something that we already had before. Right, so here we had ls, and then we know about directory A. So then we do cd to A. So we can assume that our directory that we are currently in has to have this directory. So there's no, let's say, no case here basically where we go to a directory before it was initialized. So this means we can just check and get the correct directory from our from the current directory or the directory that we want to switch into. So this means what we do is basically, first maybe we start with the first one. What happens if directory name is /? So this means basically we go to our root directory. So if directory name equals /, then we just return a new directory with name / or root, and we return its name. Why doesn't this work? Unknown field name in struct literal. Okay, this is time for Google. I need to think about how this works with multiple structs within each other. So I was assuming that we just inherit in some way from it, but this doesn't seem right. So let's go to our browser and check. Golang share properties in struct. Common fields between struct types. Maybe we should ask ChatGPT. If I have two types, any way to achieve without needing. We have type A. Just star A. Okay. Okay. It doesn't seem like this is so similar to basically in other languages. So what this means is basically we have just an item here which has a name, item, and then we would need to create a new item, but then maybe we rename those things. Then we call this info, and the info has the name, and we call, but this then doesn't work again. Okay, I see. Okay. Let's go back to the browser. Golang. How to implement an interface. Interface with, not with struct, with, how does this called, properties? Let's see. Okay, what is going on? Hello Google. Okay, but access fields, interface fields, okay. Okay. So usually in many other program languages you can have those fields shared, something like that. Okay, now what you can't do is something like this. Yeah, this is a pity because this is actually what I would like to do. Okay. I've discovered a way to do this after a fashion. So you have a person and then you have the person provider interface and then you have, oh man. Oh no, this doesn't look nice. Okay, we have to do it in a different way. Okay, so the obvious way that I would use in other programming languages is obviously not the way that we would use in Golang. Okay, seems I learned way more today. Okay. Let's go back into, so what I did here doesn't work. Not good. Okay, let's do it in a different way. We have an info, file info, and we just treat the directory as a special file. So we just, oh no, this also doesn't work that well. Is there something to have unions? So in other languages you often have the possibility to have shared data, Golang union. Oh, we need to simulate it. Simulate doesn't sound good because simulate means there's no native support for this. No, this doesn't make sense. Okay, also not an option. So Golang properties, getter, setter. Are there getter and setters? This is something that you have in Java, for example. This would also allow us to do this thing, that we just have the same. Oh no, it doesn't work. Name and then we would just define an interface and we would have multiple types that are the same interface and we store just the interface types. Yeah, maybe this is the only way to go. Okay, then we do it via interfaces, I think. Good. Okay, let's try it again. Going back into the code. So what we now have is our type, and what do we call it? File, not file, but item. We just call it item. Let's say item. Item is okay. So, and our item has a way to return basically the name. So where we just say, okay, we have this name. And this is a string. And we have the size. This is something that we need later on. So, which is just an int. Ah, no, this is not a struct, this is an interface. Okay. And now we have our file, which has the name and has the size. Int. Is this something that we can use automatically? And we implement now those methods for the file type. So do this func. We have our f file and the name, and this returns a string f.name. Ah, there's some name collision, so we need to make them small, of course. F name return. Okay, this looks better. And now we also have this file size. Size, which returns an int. Okay, and the same is true for directories. So you would need a directory has a name and it has items. Name and it has item name string. So, and for the directory we also have those methods d and d. Okay, so and as a file size we currently just print out 0, or we return 0 because we don't know the file of a directory yet. Okay, good. So now going back to what we were actually doing, basically creating our root directory. So we say our directory has a name and this is root. And it doesn't contain any items right now, right? So it's an empty directory in this case. Okay, so this means our pass command returns the directory. And since we change state, it makes across the different lines, basically the directory changes, right? After this command, we are in root. After this command, we are in this directory A. After this command, we are in directory E, and so on. So therefore, it makes sense to store the directory as a value. And let's say we don't store the directory themselves, and we just store a pointer to the directory. So we make this a variable of type pointer to directory. So then we also need to make sure that we return here a pointer. Okay, we already do this. Okay, this is nice. And then maybe also implement those that we use the pointer. Okay. So pass command, we return our directory. And here, not enough arguments in call. Yeah, we need to put in our current directory, which is directory. Okay. And then we can check if this is... So this was then the new directory. And if we change the directory, our pass command changes the directory. If new directory not equal directory, then we print out some message that says, hey, we changed our directory. Change directory to new directory. Okay, and also we need to assign it, right? We need to make sure that we actually store what is the current directory. It's new directory. Okay, so far so good. But at the moment we are only handling the slash. Okay, but I don't know. We don't care. Just in case of everything else, we just return what we got as a current directory, return it again. So basically everything else except this should now be a no-op. So an operation that doesn't change anything. So let's try to run it and see if something happens. Okay, we are changing the directory to okay. So maybe we print out also the name. Could be useful. So make this a little bit easier. D star directory string, which returns a string, and we just here return our name, d.name. Is this something that we can implement for the interface? Let's change it. Let's see if this works. Does this work? Item. Okay, invalid is an interface. Okay, it doesn't work. Okay. Would have been nice. But okay, fine so far. Okay, and now I think we can, when we have the data model sorted out, we can actually begin starting implementing some logic. Change directory to root. Okay, this looks better. So now the next things. So what are the other commands that we have? So, we are still by cd. So just first implement cd. Go step by step. We have ls. So what does ls do? Ls doesn't change the current directory, right? So at the moment it doesn't do anything. So therefore I think it's fine if we just return the current directory within pass command, because we don't need to do anything about it. So then comes the next step. We have here a file entry. So it's no longer a command. So every other case, basically there are just commands or there are file entries. We can handle this as well, where we say, okay, create our item, which is then pass item, where we again just enter the whole line, because as we see there's no prefix that we need to remove or something like that for these items. and it returns, yeah, just an item. So let's go to parse item, or create it, parse item, line, string. And what do we return? We return an item. So now we can split it based on a blank, right? So it's, again, we have always a blank. If in case it's a directory, the first part when we split it will be dir. If it's a file, the first part will be some size. So therefore, just take the line and strings.split line, and we split it with the blank, which gives us the individual parts. And then if the first part, we need to check basically that we have more that we have exactly 2, right? Because otherwise we are reading garbage. Then parts equals 2. 2 should be a number. Let's check if it's not, and then return an error or panic. Just panic. Format.error. No valid file info. Okay, now we know we have 2 parts, and we can say that first part if parts 0 equals dir. If it's directory, then we know that we need to create a directory. So we can do name is the second part. This is something that we can have in both cases. So then we just create a new directory. Return new directory with parts. Name equals name. And else, if it's not a directory, then we know we are looking at a file listing. So therefore, we need to first pass the size. So size will be string conf.r2i from parts 0. If panic, as always, and then we set the size, not directory, file size is equal size. Hi, there we have someone watching. Glad to be here. So if you have questions or something else, just feel free to reach out. Okay, let's continue. So basically our parse item has those 2 cases. And in the first case, basically we just return the directory. In the second case, we return a new file. Okay, so far so easy. This item then is something that we then just append to our current directory. So if we have here we change the directory, and then afterwards we know, or we get presented what is exactly in this directory. So therefore it's easy to just add those items then to the current directory. So we have our directory here, and then we can just append to its items, where we say append slice item, not item. We need to use the items that are already in there, right? So therefore items, and then you append our item. Okay, that was quite easy. So this means basically afterwards we can, let's step through it and see what happens. So in the end we should have, when we basically arrived at this point here, we should have one directory that is set and that contains 4 different items, each with size and with a directory if it is a directory. So let's just set the breakpoint here so that we always, or here, that we always know at which line we are at, and then just try to run it. Okay, so first line, we are at this line cd. We go into parse command because it's starting with this $sign. We go into there, it's a cd command. We get our directory name, which is just a slash. So far, so good. So, and we return a new directory with its name slash. Okay. So now, new directory. We know that the old directory was nil, the new directory is different, so therefore we print out, we changed our directory. Good. So next line. We now have this ls, so we expect that our command does something different. So it goes into command, parse command. It's not a cd, it's an ls, but in ls we don't have to change anything on regarding the directory, so therefore we just return the current directory so that it stays the same. So, and now it's the same, so we go to the next line. We have a dir a, which means, okay, we go to parse item. Okay, we should have gone into it, but doing it next time. So item, as we can see here, is basically a directory which has a name and it has nil. Okay, this is something that we didn't initialize right. But we will see. This will probably break now. Oh no, it don't. What happens here? So okay, it works. So basically, it creates a new slice. Nice to know. So we go over the next line. It's again not a command. So dive into parse item. We split it on the string. We split the string basically on the blank so that we end up with 2 strings, one containing the size and one containing the file name. Okay, so far so good. We assign the name, I'll read the name. We know it's not a directory because it has a size. We convert the size to a number. And then basically we create our new file, set the name, set the size, and return its address. Okay, so far so good. So maybe we should also add some debug log here as well, that we say, hey, we passed a new file for directory something. Okay, but this seems to work. Let's continue till the end, and we see, okay, there's just only one. Print out, this is not that much. So let's add item to item and then to directory. Okay. Good. Okay, so this means basically we can, at the moment, pass those things and add those items to our directories. So now it's time to look at other CDs that we are doing, because in the end, if we look at it, let's go through it. Is there something that... let's just print out what we have in the end as the root directory. Root directory or current directory, I don't know. Then we would need to store the root directory. Current directory items we just print out all the items that we find within the directory that we currently have, and then we would see something that is not what we are basically hoping for. Hey. Directory.items. So print it out. So, and as we see, our current directory contains B, it contains C, it contains D, it contains E, it contains F, it contains G, so it contains a whole lot of different things. So basically everything gets added to this root directory, right? Because we didn't implement this case yet, where we go to a new directory, and we didn't implement this case where we go one directory up. Okay, let's start first with that directory down, so CDA at this point, right? So if the directory is not equal /, then what we need to do is basically take a look at the current directory and find the directory in there that has the same name. So if else if we can take a look at the directory and it has the different items, and we can create some function for it that we call the directory, that we call get subdirectory, and it takes a name as a string and returns a new directory. This is basically what we can do then. So, and for this it's quite easy. We just loop over all the items that we have. So item in d.items range, and then we just check if the name matches the name that we have in our string that we have given as an argument. Name equals item.name, then just return our current item. Oh, the address. I think it's we'll see. We just return the item, and it says cannot use as a type directory. Okay, now we need to cast them, and I think this worked this way. Is this true? Let's take a look at how to cast in. So normal casts worked something like that usually, but I'm not sure that this also works for. Let's see what our compiler friend says. Invalid indirect. Cannot convert an expression of type item to the type directory. Can we do this? No, we can't do this either. Okay, let's go back to our browser. Go cast interface to type. Okay, I wasn't that wrong. To answer the question, to cast an interface into a concrete type, you do I dot and then the concrete type, where I is the interface and T is the concrete type. It will panic if the underlying type is not T. To have a safe cast, you can use OK and then check basically if OK is set to true. Okay, then let's do it the safe way, right? I think safe is better in this case. So one thing, we should also make sure that this is basically, do we actually need this? Because it could be that this is a file. So we just do directory, comma, OK, is equals to item dot directory. And this should be the address of a directory, right? So, and what is it now complaining about? Assignment count mismatch. Okay. What are we doing wrong? Ah, we don't need an equals? No. This shouldn't be it. Let's get rid of that. Impossible type assertion. Directory does not implement. Okay. What about... Ah, yeah, it's a pointer to a directory. So, and we don't use directory and we don't use OK yet. If not OK, then we just return an error and panic. Because this means we have an item that has the same name, but it's not a directory. It means that we have a file with the same name, and this is something that doesn't work, or that is not allowed. So therefore, we can just return %n is not a directory, comma item dot name. So, in the other case, we just return directory. Okay, and if we don't find anything, we just return nil. And then maybe rename this to find subdirectory to communicate that it could return something that is not there, right? Okay, so now we are here. We have our method find subdirectory. Let's call it and say subdirectory is equals to directory or current directory find subdirectory with the name that we actually passed from the rest of the command line, which is this directory name here. So if subdirectory equals nil, this means we don't have a subdirectory. So this means we have some error somewhere in our input file, which is not correct. So again, just panic and return, oh, no subdirectory with directory name. Okay, now we have our subdirectory, then it would be, we can just return it. So this should allow us basically to handle all those CDA. So let's try to run it and compare the output. So it should look a little bit differently. Ah, we still have errors, okay. Panic, no subdirectory, okay. And this happens here. Change directory to E. Okay. Yeah, this makes sense, right? Because, no, it doesn't make sense. So let's look at the debug log, what we have here. So we changed our directory to root. Then we added an item A, which is the directory. We added a file btxt, a file c.dot, and a directory D. Okay, then we go into A. Yeah, so within A, then we basically do a new ls and add a directory E. We add a file F. We add a file G and a file h.list to directory A. So far, so good. Then we change to E. And then we add this file I to E. Ah, okay. And then basically we come into problems when we want to go into C. When we want to, yeah, go into C dot dot. Yes, okay. So we are currently seeing what is the problem. So we need to know what is our, what happens when we go directory up again. So therefore we check if this directory name is ... And then we need to go up to our previous directory. So now the problem is that within our directory, we don't know what is its top directory, right? So we only know what is within one directory, but we don't know what is, we don't have a pointer back to our parent. So, and this is something that we should add here as well, where we say, okay, every directory has a parent. Oh, maybe we just do it for a string, for an item in general, because files also have parents, right? Files could also point back to their parent, that which would be a directory. Parent directory, which is a directory. Okay, now we need to implement this. So this means we have a parent, which is from type directory or pointer to directory. Here as well. Always use these pointers. And we do the same thing basically for our directory struct. So have our directory struct, have our method parent directory that we need to implement now. So func f file is parent directory, returns a pointer to a directory, and just returns f.parent. And the same implementation we can basically use for our directory, which is not a file, but a pointer to a directory. The parent. So, okay. Now we have this link back. The question, we also need to set it, right? To make sure that when we create a new directory, we basically set it also. So for this, within our root directory, we don't have a parent directory above it. So therefore we can just keep it nil. But in this case, where we basically add a new directory here in parse item and in parse file, there we have a current directory. We don't have it here, but I think this is something that we should also, yeah, or what we can do, we can add it here so that we say our directory is our current directory. And then we can set the parent to be current directory. And do the same here. So now all the files and all the directories should have this backlink basically. And this backlink then allows us to go back when we find this ... So parse item line and current directory, or directory it's just called. So where are we? Find subdirectory. Ah, no, in parse command. Yeah. So this means when we find this special directory or this name, we can just take our current directory, current, and return just our parent directory. So we don't need to change anything else, but this is something that we should change. So now let's try to run again with this. Okay. This looks different now. Our final directory where we are is basically our directory, current directory items. We should also print out the name maybe. So as items in the final directory where we are is J, it's dlog, dxt, and in K. Okay, that's maybe also print out the files, the file names. This is not easy to read here, so make this small addition where we say when we print our file, we also print the name of the file. Run again, and then it should be easier to read. Yeah, okay. Our directory is called, no, we have our file J, we have our dlog, we have the dx and the k. Okay, so far this looks way better. Change directory to \. Okay, yeah, of course, right? Here we go back to the root directory, and then we go into directory D. Yeah, okay, so this looks also quite okay, or quite good from basically the from what we print out. So now we come to the task that we actually have. So all this doesn't solve our problems that we have, but we need to find this space, right? We need to find out which directories are taking the most space. And for this, we can implement the total size of the directories and then basically just print out every directory that has more than, let's say, I don't know. We just take the root directory and then we go through it and print out every directory which contains more than this 100k. And for that, within a directory, we just sum up the size of all the items that are in there. So it's should be not so problematic, because as we see, there's already this this method size that we implemented for the directory, but currently it's returning just 0, which is not correct. So, but we should print out all directory names which are larger than 100k. So for this, we just implement it now. So within our directory, we basically have the individual items, so we can loop over them. For item from d.items, range again. I always miss this. This will definitely need some time to get used to. And then total size. We initialize this with 0, and then we just total size plus equals item dot size, and then we return our total size. Should be quite easy, right? So doesn't look that bad. So what is the sum of the total sizes of all those directories? Okay. So when we are in a new directory, then we can check if there is already what the size is, right? So we have this method here where we check, oh, we are in a new directory, and therefore we can check what is the size of it. So if directory dot size equals 100k, then print format printf directory has size directory size. So this means we should already see something. This is greater or greater equal. At most, I think it should be greater equal, but I'm not native, so therefore let's see. If this is in the end some filter, then this would be really sad. Okay, and there we see already we have one directory found that has a size larger than So we change directory to root, then we add something, then go through it, then we have directory root has size 200. Okay, but I think the problem is that afterwards we could also, this is now not at the end, right? So this, the size of the root, we calculate this here in this moment. At this moment, but we don't know what is actually in this directory D that is also within root. So therefore, the size that we are given here is currently wrong. Yeah, because only after we have been to D, we can calculate the complete size. So therefore, we would need to now loop again through it. And I think this is basically what we will do, where we go through the individual tree. So we first start with our root directory and say var root directory. And we store it. So if directory equals nil, then we know we are creating the root. Root directory equals new directory. So, and then basically we just loop through it again. And this is something that we can do in a separate method. So we need to loop over this. So we can first just let's check this just with the root directory and see what is the final size. So in the end, if we have listed all the different files, so in the end, what will be the final size of this directory? And here we can use also root directory items as root. Use the root directory only for this at the moment. Okay, run through it. Root directory, as we see, it's way larger, right? So it's not just 200 something, it's 480. Okay, so, but now how do we find all directories, right? We only have our root directory. And for this, we can create a new directory. Or we can create a new method that we implement on directory that says func it's a directory method, therefore, and print directories over 100k. So for this, we can just copy the code that we already have here. Copy it here. And use D. So, and then we also need to run this recursively on all the directories that are within the directory that we are currently looking at. So, for example, if we are looking at the root directory and calling this method, we also want to know if the directory A is bigger than 100k or the directory D. And this is something where we call these things recursively. So we loop over the items. We don't need the index. Range d.items. And then we basically do the same check as we do here. But if it's not a directory, if the item is not a directory, we can ignore it if okay. But we only want to use this on directories, so we call on this directory, the subdirectory. This is basically the subdirectory. Let's make it more clear from the naming. I should write it correctly. If I want to do this, subdirectory.print directories over 100k. We call this too. So therefore, try to run it, and we, in the end, we only need to call it once on our root directory. So root directory.print directories over 100k. And this will then recursively, because this function calls itself, right? So we have here, we first call it on a directory and then it calls itself on a different directory. This is basically the recursion. We call it again and then see. Okay, and we get directory slash and directory D, and they have a size of 400, I don't know, and 200 something. Okay. So now the point was we should, let's check if this is basically what we also have as root content 483. This looks fine, and total size of D is 249. Let's copy those values and in order to be able to compare them. For this looks the same and this also looks the same. Okay, so we are calculating the same sizes, which is quite nice. But now we just shouldn't print them out, but we should print out the total size, right? So we need to return them so that we know what is this total size. So, and this is something that we can implement here as well, where we just return an integer and we sum up all the files, all the directories that are bigger than 100k. So if our size is bigger than 100k, what we are doing is basically summing up total size plus equals total size plus equals d dot size. And the same happens here. So basically we also need to sum up what is returned by the subdirectories. So we also do this total size plus equals, so, and in the end then we return total size. Okay, let's print out what is in the end the total size. Total size and print total size of large directories is total size. And as always, backslash, and so. Okay, this is our total size. 73,314,807. Is this correct? So it should be basically the sum of those things. I think it is correct, but we don't get this. This is not nice that we don't get that the totals. But okay, I think we can be quite confident, right? So let's try and add this directly here and run this on our input data that we actually got, that we should solve, and we see root directory items. Okay, this is way larger, the directory, and the total size of large directories is, I don't know, something of 240 million. Okay. Oh, sorry, I didn't show the result. So let's go again. We just changed the input. Run it again. We have this as a root directory. We have a couple of other directories that are bigger than 100k. And in the end, this is what we got as total size. So copy and try to see if this is correct. No! What the fuck? What? It's not correct? Okay, this is bad. Let's look if we see something interesting within our lists of files that we have here. We add a couple of items. We add okay, now it's becoming weird. Okay. Let's print it out in a different way. So when we go through it, we need to debug this now. And for this, it's always useful to have the hierarchy visible, right? Where we just print out every directory with its name. And so for this, we add some indent that we use. And we call this with plus indent. So, and then we print out every directory with a size. We just print out the name and the size. I think this is good enough with the correct indentation. Okay, run it. And now we should have something else that we can look at. Okay, I'm wondering if the problem has to do with our data type, if there is at some point. So our root is this. This is 48 million. Okay. Let's print it also with the total size. Ah, I think I see what we are doing. I think the problem might be that we only need to sum those things up if, where are we? Yes, we only need to sum those up basically when we know that the current directory is larger than 100k, right? So it doesn't make sense to sum up all those individual smaller directories. But this returns the same result. Or does it? So if the size is larger than this, then basically our total size is our size, and then we add also the sizes of the subdirectories. Okay, let's try again. I'm not sure if this is actually the same size. It is, so therefore it's probably not correct. Okay. So we know that we only need to take a look at directories that are larger than 100k. If the size of a directory is smaller than that, This is 100k. Then we can ignore it. So we add it. Okay, let's read again through the since the disk is full. Your first step should probably be to find directories that are good candidates for deletion. To do this, you need to determine the total size of each directory. The total size of a directory is the sum of the sizes of the files it contains, directly or indirectly. Directories themselves do not count as having any intrinsic subfile size. But this means, indirectly means that the size has a total size because it contains files f, size g and h, plus files I indirectly because it's, yeah, directory D has a total size of, but these were the right correct numbers. At the outermost contains every file's total size. So it's not, I assume that not our, what we implemented so far is completely off the rails. Let's compare again. 483,000. No, 483 48 million. Okay, 48 million and 24 million 73. These numbers are correct with what we calculate. Maybe at most is wrong. Okay, let's check. Google Translate. This is really awkward to have to at most. Oh no, there was Translate. Oh man. Google Translate at most. Maximal. Nicht mindestens. Okay, to begin, find all the directories with the total size of at most 100k. Then calculate the sum of their sizes. In the example above, these directories are A and E. Ah, okay. So I'm counting. Okay, I'm counting the large directories, which would make sense. Would make more sense to count the large directories. Okay, but this is wrong. So we are doing this in the wrong direction. Not over 100k, under. So, but I don't understand the use case. Why should we implement those under? Because it makes more sense to delete those that are basically larger to get more space. Total size of large directories, of small. And there's still something funky going on because it's, if the size is smaller than 100k. So the size of 0 is something that is wrong. Ah, now again we need to go out, right? So we need to run through all directories, even if the directory that we are looking at is larger, because there could be smaller directories within there. Okay, and now we have 94853 and 584, so the final result will be 95437. 954 is, yeah, okay. Sorry. This was totally wrong, but I was completely looking at the wrong number. This is bad. I hope we will still get some accomplishment. But at least we learned something about understanding English. So total size of small directories 1.2 million something. So just use the input txt, run it, and try again. Submit. Okay, 1 gold star. Whew, this was harder than I expected. But okay, it's problematic if you are not understanding the puzzle completely. So now you're ready to choose a directory to delete. The total disk space available to the file system is 7. What is it? 70 million. Okay. 70 million something. To run the update, you need unused space of at least 300 million. You need to find a directory you can delete that will free up enough space to run the update. Okay. In the example above, the total size of the outermost directory and thus the total amount of used space is 438 million. Oh, no. 84 million. The unused space? Ah, okay, in the unused, okay, in the example, which isn't quite the 300k required. Therefore, the update still requires a directory with total size of at least 8 million to be deleted before it can run. To achieve this, you have the following option. Delete directory E, which would increase unused space. Directories E and A are both too small. Deleting would not free up enough space. However, directories D and / are both big enough. Between these, choose the smallest D. Increase unused space. E and A are both too small. Deleting would not free up. However, directories D and / are both big enough. Choose the smallest. Okay. Find the smallest directory that, if deleted, would free up enough space on the file system to run the update. What is the total size of that directory? Okay. So total disk space is this, which is, okay, let's copy it over so that we have it available. Total disk space. So, and in the same, there was, same way there is the minimum disk space, or what was it called? Unused, required, unused space. Okay. Required free disk space is this. Okay, so now let's see which directory would we delete. So we need to find the smallest directory that, if deleted, would free up enough space on the file system to run the update. So what is the total size of that directory? Okay, so for this we can use some list basically. Is there some priority queue or something like that? So basically what we need to do, we need to find all directories. That is something that we do here. Basically we can just append all directories that we encounter. All directories, so just store them so that we have a slice of pointers to directory. Is equal make so this means every time we are changing the directory, basically we can, are we creating a new directory? No, it's the same. We just check if we already have this within our directory, in all directories. So if directory in all directories. So and now the question is, how do we implement this? I think we had this yesterday. Is this correct? This duplicate. Oh no, this was using a map. But we could use this as well. Oh no. No, I don't think so. So we have our list. Let's check how we implement contains. Colon contains slice. Method for a slice. Starting with Go, you can use a slices package. Something is really funky with the internet today, I don't know. Yeah, this looks good. It just loops over all the individual. Yeah, okay, this is too easy. This is something that we can actually. For a in all directories. In all directories, if existing directory equals new directory, new directory, then exists, false, stop, exists equal true, and then in the end, if not exists, then we just edit all directories append directories equals append all directories new directory. Okay, so this means basically when every directory that we go through within our test data, we will just store it in one single list. So this single list allows us then basically to find the correct or the item with the minimum space that will be freed afterwards. So this means, how do we get the total? Oh, there. How do we get the total? So the total amount of, and thus the total amount, the size of the outermost directory, and thus the total amount of used space is 483. Let's check if this is actually the case. I'm wondering if they are currently talking about different spaces. Root directory. Use the input, the test input, test. Root directory space or size. Root directory dot size. Okay. Let's comment those out. We don't need them currently. Okay, this is the number that we have there as well. Okay, so this is fine to use. So now we know what is the total size. So this means required, maybe we should write this correctly. So we can calculate what is the amount of space that we need to free. Space need to free this space is the total disk space minus the root directory size. So this is basically how much is currently free, and then basically we from this what is currently free, from the required disk space we subtract what is currently free. Maybe we can just make it current free disk space. Add this and just use it free disk space. So, and we need to make sure that we again print something out to see if it works or if it's logical. Need to free at least need to free disk space. So this is the 8 million. Let's check 8 million, but I think this is the number that we also have within the puzzle. Yeah, this update still requires this 8 million. Bam, bam, bam. Choose the smallest. Okay, going back to coding. So now we can basically loop over all those directories that we have for the for the in range all directories, and we always store what is the directory that we should delete. So to delete, and then which is star directory, and we also store the difference between what would be the how much free space we would have after, and this is what we try to minimize. Free space after deletion, and we initialize this with, I don't know, is there something like int max int or something like that? Or just make an insane amount. Okay, this is currently our amount, and then we loop over all those directories. So if need to free disk space minus free disk space minus the size of the directory. Oh no, if the size of the directory minus, so the directory needs to be bigger, right? Need to free disk space, otherwise we don't need to delete it. If it's smaller, this doesn't help. So it has to be bigger than 0. Oh, 0 equals, maybe there's also 1. If the directory of the size, the size of the directory is bigger, minus the needed free disk space is bigger than 0, then, and now we also need to check if this would be better than in the current minimum that we already found. So, and it's okay. Let's calculate this. Free disks freed up. Freed up disk space. Is this a word? Freed up? I don't know. But somehow it seems to be okay. So if freed up disk space is bigger than 0 afterwards, and the freed up disk space would be smaller than our free space after deletion that we currently have, then we just store our directory to delete and store there the current directory. And we update the free space after deletion to be our freed up disk space. So to delete. So, and then in the end we print out deleting directory would free and what would be, how much would be to delete and free space after deletion. Okay, let's run it. And we see deleting directory D would in the end free up 165, no, 1,600,000, no, what is it? 60 million. Okay, so it would definitely free more. Okay, let's see. This was also talking about the increasing the unused space, yeah, by this amount, but we already got. So now let's give it a try, how it works for our input that we got. Input, run. Okay. Yes, this is something funny over here, because we get here a negative number. Negative number should not be the case, right? Ah, it should be bigger than 0, and both of those conditions need to be true. So we can only use it to free it up if it is bigger. So if it's big enough, so that this is bigger than 0, and if it's smaller than what we did before. So therefore not or but and. Run again. Need to free at least 8 million something, 700, and this is one directory that is basically, oh no, this is also, would free something along the line. Yeah, okay. So what should we submit? What is the total size of that directory? Okay. So we don't need to, would free, not the free space is the important part, but basically the to delete dot space size. So so we have one directory which is 9 million big, 9,600,000, and this would be enough to free that. Okay, let's try copy and see if this is correct. Okay, and we made it. Okay, this was way harder than expected today. Sorry for all those interruptions and back and forth and so on. I hope you learned nonetheless something. As usual, the solution will be online later today, and I will also upload the file to YouTube. So yeah, as always, stay curious and have fun with the advent of code, and would be interested to see how your solution would look like. Bye, everyone.